So hello, Internet. I'm Brian.
Hi, Dave.
Welcome to PinDevCon 2023, a sub-conference of the Northwest Pinball and Arcade Show. PinDevCon brought to you by FAST Pinball, CoinTaker, and Planetary Pinball. This talk is, what do we call it? Modern pinball machine wiring.
That's what I believe I read on the outside there. So
yeah,
yes.
yeah. And so we're specifically talking about, FAST Pinball platform. I'm one of the members of FAST Pinball. Dave, you're co-founder of FAST Pinball.
Yep, I do all the hardware. I basically tell myself I tame electrons. That's what I do for a living. So
and so what we're going to do for this session is, so I joined FAST Pinball about 1.5 years ago. My background was technical documentation and technical writing. And so I spent the past year or so writing all of the FAST Pinball technical documentation, like wiring guides, how-to guides, all that kind of stuff. If you go to fastpinball.com and just go to our homepage, I don't know why that wasn't linking there. There we go. So fastpinball.com, go up to docs from the list, and here's our technical documentation homepage. And this session here now is about wiring pinball machines. So I want to go to our wiring guides, which you notice over here. We have important concepts, and then we have free play 40 Internet. So there's your ramp guy. So we're gonna look at wiring guides today, like the neuron wiring guides. And so we have these wiring guides that we created, like introduction to wiring, how you wire your power supplies, like how you wire switches, how you do your ground, all that kind of stuff. So I'm walking through all this stuff right now, and all of this information I got from Dave's head. So I wrote this documentation, but Dave's the one that told me what to write, basically. So I think what I want to do right now for this session is if you're about to wire up a pinball machine, let's just walk through all this wiring documentation and just kind of get some thoughts on it.
Absolutely.
So I'm going to begin at the beginning. And if we go to, oh, funny, this thing expanded all the way. No, I've never seen that before. I'll just refresh there. There we go. Important concepts. Okay. So in our for the wiring guide, we first have an overview, and this is where you've got your baseline skills and then platform specific. So if you're wiring a Neuron versus wiring a Nano, there's different wiring guides because there's some changes there. We're not going to focus on the Nano today since that's our older platform. But if you look at the baseline wiring skills and knowledge, the very first thing is how to crimp wire connectors, and just the very basics. Because a lot of these wiring guides, you buy wire by the spool. That's the first thing. You're going to buy a lot of wire in pinball. And you're cutting it to length. You're stripping off the ends. You're crimping the pins on, plugging the pins into the headers. And
there are some really important things, especially on the wiring.
Sorry, let me just hook you up here. Okay, try that.
It's so confusing because there's so many, if you buy it on price, you'll be really surprised sometimes in what you get. There's aluminum wire that's got some type of coatings on it. Solid wire is not very good for pinball machines. I bend it a few times, it breaks. So anyway, there's some really good guidelines, on the website of what kind of wire to buy. So, buying the right tools to do this job is going to make it go a whole lot easier. You don't crimp right, wire comes off, goes to short something you don't want to short to. So yeah, this is getting started. This is an excellent place to start. Good wire, a good tool.
And we have a wiring standards and guidelines, which we explain wire types and gauges. We use mostly 18 gauge and 22 gauge in Fast Pinball land. And we explain the gauges here. We explain the wire type also. We won't go through the details, but like you said, there's aluminum wire. There's aluminum wire that's covered with copper. You want wire that's stranded wire because it's made to bend, and you want solid copper wire. And a lot of the wire you get on Amazon, it might say copper wire, but it's actually, if you cut it, it's aluminum on the inside.
Copper plating. So don't be fooled. If it seems a lot less and you think you're getting a good deal,
yeah,
you're probably not going to end up using it. So just know this.
Don't buy wire from Amazon is what we say basically. I mean, we have links of different wiring vendors. You can get, there's certain UL standards for wire that we list here, and it's I bought, but again, if you have to trust not to just the UL standard, but also the source you bought it from. Just because a wire on Amazon says it's UL listed, Amazon is not going to be hey, this pinball machine melted, and I bought the wire, and you said it was you, like Amazon. Don't buy wire from Amazon. The other thing too is we have standard wire colors that we use within the land of fast pinball, and so these colors are like, I mean, you can use whatever color you want if you're building your machine. Hey, it's your machine, and there aren't really like specifications for colors inside devices like pinball machines. But we say if everyone uses the same colors, now like we make all of our diagrams have those colors too. If you are stuck and need a picture and are posting a picture into Slack, if everyone's using the same colors, then it makes it really easy to understand. Like,
Yep, we know what we're looking at.
Blue is 48 volts. Red is 5 volts. You know, like these kinds of things. So, so we sort of explain the colors. By the way, in our wiring diagrams, all our switch returns are orange. All of our driver returns are white. You might want to use different stripes or different colors or whatever. Go ahead and do that inside your machine. But for the diagrams on the website, it's easier just to see, like, if you see a yellow wire, you know it's a switch. So I'm going to hook on one more time. I'll try it the other way. So I'm disconnecting back here. Pause for program notes. It's a tech conference. I can't get it without capturing your hair. There we go. That should stay up there now.
Okay.
Okay. Okay. So, oh yeah, the 2-color striped wire is a thing too. Everyone wants to know. Like old pinball machines had the like a main color and a stripe. Hey, if you can find 2-color striped wire, go for it. But you know, Dave, you talk a lot about the old pinball machines and our forebears and what they did. And you have to remember, in an old pinball machine, all of the control was up in the back box. So your transmission bundles are like these like 1-inch thick diameter with like 1 billion wires in them. You need 64 different wire colors to have all this stuff. Nowadays, with I/O boards under the pinball machine everywhere, like all the wires are really short. Yeah, so you don't need. I mean, you might want to have a few different colors for switches just to keep them separate from its two neighbors, but you don't need 64 different color combinations in wires anymore. All right, so next topic is ground and grounding. This, you can talk an hour on this.
Yes, it's, you know, and it's the thing too that you can't give a lot of solid advice here as to what really to do, because it depends. The most controversial thing is earth ground versus ground in a product, because earth ground is more for safety. You know, if you have a metal product, for instance, every metal object on the outside of a pinball machine, the lockdown bar, the legs, you know, any screw that you can touch on the outside or bolt needs to be sit there in some way or another going to earth ground. And this is so that if, you know, some wire came off, some hot line may have been touching some metal object in the pinball machine, and someone went to go touch that, they could be shocked or killed, you know. So there's a few disclaimers that when you read in here too about this topic. But the big controversy is like whether you tie this to your ground in the pinball machine ground to earth ground. And so I'm not going to touch a lot on that because that's
overhead voice. You know, and the thing is also, I'll wait until overhead's done. How's our sound, Eli?
Sound okay? I'm still sound a little quiet myself. Can you hear me okay? Audience can hear fantastic, great.
We're on the show floor in our little corner of the actual pinball show itself, so we get like the overhead announcements and that kind of stuff. But,
and I could never hear them anyway. I don't know why they do these announcements. It's really just to annoy us.
I think it's only speaker above us. Well, I'll try. This understanding grounds and ground lines, like, I can't, we'll wait till it stops.
Is there any questions from the audience so far? We're all good.
I'm sure you can't hear this in the video. It's really loud in our ears in real life. No one can hear us while this is going on.
And I can barely hear you, so it's like, I don't know what could this
set up a preview.
You know that?
I didn't realize that we should set up a preview monitor back to us. Like, I didn't realize it'd be so loud.
All right, it was something about raffle tickets.
Okay.
All right, excellent. It sounds like it's over.
man, we're 20 minutes in. Let's get moving. It's the thing with this, the understanding ground. This is basic like science concepts. Everything we do in our pinball wiring guides, we try to be as practical as possible. But there's some things you actually have to know, like ground in a pinball machine, like on paper is 0 volts. There's no such thing as 0 volts in real world because wires have resistance. And Dave, one of my favorite sayings from you is that, you know, a wire is just a very long and bendy resistor. Even 2 feet long, there's resistance. And Ohm's law basically says that for a given amount of current, if you increase resistance, the voltage goes down. Or voltage, staying the same and resistance increasing, then current goes down. Like there's a ratio. So when you have a coil that fires and it takes a lot of current, that current shoving through that resistance lowers the voltage. And we'll talk about that's what the capacitors are for and the power filter board and that kind of thing. But you have to understand that these wires, you can almost think of like the electricity and the electrons like water flowing through, and it's like pushing and pulling and moving and like a lot of water through a skinny pipe. It's not going to go as fast unless you like push it like really, really fast, but you can't push it too fast or else you have like a water cutter jet now.
So what helps me out a little bit is just really looking at wires. I see them as resistors, and with all these different boards and different areas of the machine, if you kind of look at more like, it's not a solid connections, these things can vary. I feel like I explained to people that the boards are kind of floating. So, what are the 2 things that cause them to float away from each other the most? Well, magnets and that dang flipper coil that's almost a dead short. The main coil on a flipper is it is a dead short for 14 to 18 milliseconds.
Yeah. And why is it a dead short? Because a dead short has very little resistance. With Ohm's law, what does little resistance mean? A lot of current can go through. We want a lot of current to go through.
We want that flipper to move, get the power we all love so much.
And that's why we have slow blow fuses in pinball machines also, because if it was a fast blow, like every time your flipper flips, it's a dead short.
But let's talk about how bad that ground is going to the flipper and the driver. So, a flipper main coil typically will take so we got to say we have 48 volts up here, we got ground up here. There is usually a 2 to 3 volt dip in 48 volts going down and then ground coming up at that same time. Because, you almost have this dead short there. So with the resistance of the wire, here's some simulation that I did.
The blue is the 48 volts and the green is the ground.
Yeah.
And then firing the flipper with almost a dead short, you see how much the 48 volts drops down, but you also see the ground comes up. Which is a problem if you share this ground with like your electronics and stuff as well.
Yeah, so let's take a look at some, digital grounds like, 5 volts, 3.3 volts, 12 volts is used for other things in the system. So if somehow you have those grounds tied in such a way that this 2 to 3 volt, rise in ground is attached to somewhere else that's controlling your 5 volt logic, it's simple math. Take 5, subtract 3, what do we have? 2. And is your processor running now at 2? Probably not so well. So, if you start looking at all these things like floating around and, what is the main pipeline? If we're talking about like fluid and like, you have a 4-inch pipeline as your main out in the street, and you come to your 1-inch line to your house and now you're 3/4 by the time it hits your, shower or something like this. How bad does that really get? And where is the best place to go? Well, if all of your delicate stuff was way back on that 4-inch line, all of a sudden you don't see the dip. It's like whatever's happening down at your neighbor's house, whatever, it doesn't affect you at all because you got this big, beefy 4-inch line out there. So that's how it works in plumbing. That's how it works in electrical. If you try to share a whole bunch of wires with one little line, not going to work so well. So the main thing is we have some references in the thing, but what is ground zero? Where is the 4-inch line in a pinball machine? And we try to make that at the filter board. So if you can get all the wires back there, and a filter board is nothing more than just some capacitors right after your main 48 volt and a 12 volt supply in the Neuron's case. So this is where ground zero is. This is where the 4-inch line is. This is not going to move hardly at all, no matter what your neighbor's doing, firing those damn pesky main coils and their flippers. It's not going to affect you.
And so this is, part of this document, as I said, understanding ground lines and grounding in a pinball machine. This is sort of, again, some of the pre-read stuff. We talk through the specifics sort of later on. But we've got all the background information there for those who want to get into the science and that sort of thing. Conversation on power supplies, I'm going to avoid that for the moment. We'll come back to it. So here's the main thing. If you go to our fastpinball.com/docs, you look at the wiring guides, how to wire a Neuron controlled pinball machine. The very first thing is we show like what goes where. And this is my own little, everything can't fit on here. Actually, let's see. This is my own little, I draw in PowerPoint, so it's my own little art for like what happens. But just kind of like laying the land. Here's what a fast pinball machine looks like. In the back box, you're gonna have your host PC, you're gonna have your Neuron, which is your main controller, your audio board, your power filter board, and your power supplies. So all that stuff is in your back box. Then all the other boards, like your I/O boards and the expansion boards to drive lighting, the I/O boards for switches and everything, all that is inside your cabinet or underneath the playfield itself. So fundamentally, this is just kind of like this is our map scene right here. This is like our overall world overview of what a pinball machine wiring looks like. It's different than the old days when everything was in the back box.
Yeah.
And then when we talk about, I go into some specifics in the documentation. Here, then we have all the like step-by-step wiring guides for every kind of thing. So we show you how to wire your machine from the AC power outlet all the way in. So very first thing is how to wire AC inputs. And so we're talking about the power supplies and how that is wired.
Now I know we talked only 18 gauge and 22 gauge wire, but there are exceptions. And the one area that when you have that line cord coming in, it may be necessary to run 16 gauge wire. So mileage may vary. Check the inrush current or your power supplies and your fusing to determine that. But yeah, 16 is called for in some cases.
Yeah, and so what we have here is this is a drawing of like what your power box should look like. Because what you like to do, Dave, but we talk about a power box or like a lunch box almost. Your line in is going to be into the back of the machine, and so that's where you're plugging your cord in. You'll have your power supplies in there. A fast Neuron-based system only uses 12 volts and 48-volt power supplies, which is great. No 5 volts. Now, a lot of things run on 5 volts, like LEDs, but what happens is all power being distributed to all the boards is all 12 volts, and then the little boards themselves, they generate whatever local voltage they need. And there's a lot of reasons for that.
Yeah, the main reason is that, Ohm's law affects you once again. Long runs of wire with 5 volts running through them, lots of current. Pretty soon the voltage dips, so by us putting it local, we don't run into those same problems with the voltage.
Yeah, like people, with the long LED chains, where the LEDs like discolored a little bit at the end, it's because your power supply is 5 volts, but then it goes through like the filter board and this connector and all these wires and this other connector, and there's resistance in there, and you measure at the board and it's like 4.8 volts now. So you already lost, 5% of your power, and then the chain itself has resistance in it. So by sending 12 volts to the board, that means when that board generates its 5 volts versus LEDs, it's actually 5 volts down that entire chain.
And some people may also wonder, like, what is this line filter all about? Because that's kind of foreign to a lot of people. Probably never seen that in a lot of electronics. One thing we try to do at FAST is try to give you the best practical design to make sure if you ever do go to a testing facility, testing lab, that you will pass emissions. So a lot of times pinball machines from the power supplies, all that other stuff, it will couple back into the ground plane or other areas. So this filter, what it really is just an EMI filter trying to get rid of the stray gremlins that are going to cause you to fail in an FCC lab at the power cord. So that's what that's all about.
And I should say all of our wiring guides and our wiring documentation and all of our products are built with the idea that if you build a machine and followed our guidance, you could get that machine UL listed and would pass FCC certification and CE in Europe. Now, that's a very different world. There's different professional standards and professional engineering, and the disclaimers about yada yada, and your situation might vary, and it depends if you have the exact right parts. But generally speaking, if you follow our guidance, we build stuff that can be used safely and in a compliant way. Which is why, for example, the power, we want the high voltage. It's in your back box. You put your 2 power supplies in there, and all this wire right here is all running 120 volts or 240 volts. You put a metal cover on it. And now it's protected and completely isolated. I want to go back though, because one of the cool features of the Neuron is that we have, where is it? The design choice. Will you use the Neuron's soft power control option? Because this option right here is showing the traditional option where it's like a hard switch, like on and off. And that's fine, but it's has some downsides. Like number one, if you plug your power into the back box, well, now your power switch is all the way in the back. And it's like, oh, you can put a power switch in the front, Now you have AC power, high voltage in your cabinet. Now you got a whole different league for UL and all this kind of stuff. Trust me, it's way easier to keep all that high power in the back in that little metal box, much safer. So this soft power control, which is this really great feature that Dave invented, allows you to have all this high power stuff in the back, but a remote soft switch in the front that turns the machine on and off. What's also nice, because it's a soft switch, is you can hit that button and then it can power the computer down cleanly, and then the computer can turn itself off. So you don't have like these hard outages. So this is the traditional way to wire your machine. You can also go down, I'm gonna skip down to the, oh, you know what, it's in the next section when I talk about that, which I'm just gonna move on. We talk about the importance of using crimped connections. Don't just twist your wire and stick it under there, because a stray hair is going to touch the neighboring and you get a little spark. So, power supplies, by the way, we do have links to power supplies. If you buy our starting bundle, we'll include power supplies. But if you don't buy our power supplies, we have a document. Where is it in here? Choosing the right power supplies for your pinball machine. I won't go through that, but all power supplies are not created equally. Here's what you need to look for when you're picking a power supply, and here's like, I got some data sheets on there showing you what you're looking for and like why you're looking for that sort of thing.
But in a nutshell, here's a big thing. Is that, the 12 volts, you're just going to kind of like do your 12 volt power supply based on what your power budget is. It doesn't really change much. Okay, that shaker motor you have in there, okay, allow enough budget for that. But when it comes to the 48 volts, like I said, these flippers are almost like dead shorts when that main coil kicks in. I mean, they'll blow a 4 amp fuse in just a fraction of a second. So there's a lot of current flowing through those coils. So if you use a power supply, you have to be aware of how does it overcurrent, because even if you put caps in front of it, caps will delay it, but you're still going to see the surge. So you want a power supply usually that will go into constant current mode, meaning like it's lowering the voltage, but it'll come right back up. A lot of other power supplies will do what they call a hiccup mode or something. They'll disappear for 2 seconds and then try to come back into the load. So
you know how the pro players try to like flip a bunch of times before a ball ejects out of the book to starve the power supply so it doesn't go as much power? If you design this machine based on our specs using the FAST platform, your power players will not be able to do that. So that book will always have the same amount of power. But the next guide talks about the soft power switch wiring, which is using this thing called a solid state relay, which this is basically a relay, but like made to, it's a relay, but it's solid state. So it's made to stay on and carry line loads through it, and it's controlled by the neuron and a little starter, little button cell battery. I won't go through all these details, but what this does allow is if you put that solid state relay in there and a thermal fuse, because we want to be safe with everything. And if your relay has a problem and overheats, you want to know about it and shut it down, not anything worse. But if you do this wiring, by the way, this switch allows then 2 directions to be always on, always off, or soft control. And this is how you wire that. And we even show the diagrams of like, okay, well, how the power is flowing through there so you can understand. Let me switch the other way. So
we should probably talk about why, like, one thing that's really weird about pinball machines, like everyone seems like they know where the switch is now. It used to be a long time ago, if you're in an arcade, only the operators know, okay, it's under there, or it's in the back box, wherever now. But, I always thought that was kind of dumb, because someone turns it off and so, oh, hey, just someone turn the machine off. You turn it on, and if it was smoking, it's still smoking when someone else comes by and turns it on. So, yeah. Anyway, one of the cool things about putting this power switch in the back box is, number one is the switch underneath is a soft switch. It's not really turning the power on or off directly. And then if it needs service, you can literally turn the power off to off with that 3-way switch in there. And now no one can turn it back on with the switch on the bottom. It is off.
Yeah, and I like putting that 3-way switch on the inside of the back box, so it's almost like power control mode as opposed to like a power switch.
And then the other thing you can do is that if you don't want to use, like a lot of places will just sit there and blow the breakers every night. If you're a big facility and all that kind of stuff, you don't turn off every individual machine. So now the soft start is actually in your way, because now it's one extra step that you have to do to go hit, anything that has soft start on it to go start. So we have an always on mode, an off mode, and then a soft start mode. So that's kind of what this is kind of representing.
And that's all the homebrew makers are doing this now too, because again, you can shut down, maybe they don't have the skills to harden their computer to go down, hard. And so they can do that. So explain that in the different options here. So next, okay, so now we got our power supplies, which means you got 48 volts and 12 volts coming out. So what's the next thing? The next thing is you connect to the smart power filter board. And I guess we have all these sitting right up there at the booth. Like,
Could be holding one
I
up
could've-
right now. It could be
but I
down
got
a
a
white.
better picture on here. So the power filter board, we've had a power filter board for years and years and years. This is a smart power filter board. And so what this board does is, you see it's got the 48 volt input and the 12 volt input. By the way, the number of pins that are on here match the number of screws on your power supplies. There's 3 screws for plus 48 and 3 screws for the 48 ground. And you have 3 screws, 3 screws, 3 pins, 3 pins. Because we want multiple parallel wires for lower resistance, so we have not as much of an impact on these, like these high current events. So everything was designed to fit together, and if you follow all the directions, you will wire it properly.
And the one thing I really love about the new board is like the pins for everything match all of our mating hardware downstream. So our playfield interchange board, for instance, plugs right down to the bottom connector on the lower left. And so it's a 1-for-1 correlation to that board. And then the power distribution up on the upper top there where it says going to the Neuron, the back box topper, these are all 12 volt taps that, match the 12 volt taps that are on all those specific things. So anyway, it's almost paint by the numbers. If you sit there and follow the guides and just sit there and do some one-to-one connectors to all these various boards, it's like your experience is going to go well.
What's really cool also is it's a smart power filter board and it has smart features. So there's a processor on here. And Dave is our hardware designer. Eli is our firmware engineer. Eli's running the camera switcher now. Hey, buddy. Eli wrote all the firmware for this. So this Neuron monitoring, this smart power filter board, you can plug into our expansion breakout network into a Neuron, for example. And now the Neuron knows if the fuses are good or not. So we can actually monitor the fuses and let you know intelligently if a fuse is good or not good. And on the 48 volts, it knows what the current draw is on the 48 volts, which does a lot of things. Like if you have, number one, if you have a short on your 48 volts, it would blow the fuse. The guys won't let me say this objectively, but in many cases, the current monitoring can notice the current spiking way too high and cut off the 48 volt power, possibly before you even blow a fuse or damage a MOSFET. So that's cool. Also, when you turn the machine on, if it notices there's that, whoa, it's like, ramping up the current and it sees it going off the limit, shut it down. And now we can know, like, there's a current problem here and we're not going to power it on all the way. And then the game writer, like in Mission Pinball Framework or whatever, you can actually have a mode where it starts pulsing the outputs, like enabling them like one by one, or the boards one by one, or like trying to figure out where that short might be. I don't know if that would work exactly, but it
is cool. And so
there's a lot of
we've done a lot of really neat testing. And the other thing that wasn't mentioned is we also monitor all the voltages from here. So now in your software, you can tell what the voltages are going to each fuse. And,
so like people put those little like voltage monitors, like those like little dedicated LED things. You can actually do that on your game display. You can make a dashboard, you can like whatever you want.
Do your own brownout detection software if you wanted to.
Yeah.
And we should probably mention, there is, you'll notice that there's 48 volts on 2 fuses, 48 volts number 1 and 2. We talk about the back box 12, cabinet 12. We don't talk about the host PC voltage. And the reason for this is there's some variances on what some PCs require. Some require 12, some require 19, some require 22. So even though we monitor the voltage, we have a fuse for it, we do let you put the a separate supply in and out for that. So we fuse it for you, but that's why we don't call out that voltage or tie it to the other rails.
Yeah. And then, so the wiring guides, these go through everything like step by step, right? So here's like, understand what the smart power filter board does, but we walk you through, how do you hook up your power supplies? Like 3 wires. Yes, you need 3. Do you need 3 of each wire? Yes. Here's a 12 volt power supply. Here's if you're having a host power supply from 12 volts. Here's host PC from different voltage from 12 volts. This ground tie point we'll come back to, explaining how that works. And then showing where all these other things go, right? The expansion board, the host PC, the Neuron display, these, the playfield interchange board, everything that's in the wiring diagrams, it's like just showing you step by step, explaining everything, what it does, what the connectors are. Even little hints like this. Ask us how we know. Make sure these wires are long enough to fold the back box down. Seriously, this could be like several, like the back box goes way forward. And remember, you need the wires to go like both ways, right? So like, make sure these wires are long enough. Like for real, following these guides will make it, like we've learned a lot of life lessons for you that will carry on. So yeah, moving on to our next boards. Next is ground wiring. And, you talk about how there's no such thing as ground. There's like earth ground, chassis ground, clean ground, toxic ground, safety ground. Like there's all these different things. So this page talks through like all the different ground wirings and what you need to know.
And it's probably best to go get that online and stuff. Like I said, things are floating. Some grounds are more sensitive, others, like for instance, the switch grounds. We want the switch grounds to be clean. If you have those tied to some coil that's dipping 2 to 3 volts, that might just, some systems look like a switch is just pressed. So
we'll explain like the ground tie points and how you use the ground tie point and what you tie together. And even there's some things where we cannot give you guidance on what to connect right here, but we explain why we can and what the things are to look at. So again, like just trying to help you through everything in your machine. The next thing, and this is what I love about this documentation, is how we haven't wired any switches or we haven't wired a flipper yet. No playfield wiring. It seems tedious, but we're doing it safely and properly. Like fuses. One of my biggest things since I came to FAST Pinball was like I got an appreciation from you on like the importance of fusing and the importance of blowing fuses. Like you want to talk about like buy a box of fuses. You can get like 10 each of 50 different values for like $5 on Amazon, and spend a day blowing fuses. Blow them every which way and understand how they blow, when they heat, what you can blow. Like just figure out how fuses blow. And why do you like people to blow fuses?
Because they're more of a time delay device than they are actually a fuse device. If you see a 6-amp fuse, a 6-amp fuse has to sit there and carry 6 amps, but for a period of time. And this is what a lot of people don't understand. Like when you look at some of those charts, you might find out it might take 5 minutes at 6 amps to actually blow that. So now if you have a 6-amp power supply current limited with a 6-amp fuse, the answer is that fuse is never going to blow. So this is why it's really important to test, because typically on a 6-amp power supply, the biggest fuse you probably are going to want is somewhere around 4 when you look at all the charts. So,
and I want to go into someone's garage who has built a homebrew pinball machine and find like that jar of blown fuses. If I don't see that jug of fuses, I'm like, because people are like, I never even blew a fuse in my whole machine making all, and I'm like, oh my god, I'm not going anywhere near this thing. It's a trap. I mean, like because fuses are cheap. You want your fuse to blow first, because if your fuse doesn't blow, how do you say it? Anything becomes a fuse if enough time and current.
Enough time and current, everything becomes a fuse. And
I don't want the wire to become a fuse. I don't want your pinball machine to become a fuse. I don't want your dog to become a fuse. I want your fuse to be a fuse.
The problem is it does go somewhere. I mean, if that fuse doesn't blow, if you have a dead short and that fuse doesn't blow, then it probably is the coil or it's probably something else. So it's like, and if the device, depending on the size of it, it may not fuse. It might just sit there and char your playfield, catch something on fire, do something horrific. So the thing is, it's really good to understand this. It's not just good. You need to understand this.
Yeah.
It's not just good. You need to blow a fuse.
And we explain all the basics here, because I think a lot of us, especially like there's a lot of egos in pinball building. You wouldn't build pinball unless you were fundamentally interesting. Most people who are interesting have big egos. Like we all know about voltage and amps. Thank you very much. So, hey, just so we're all on the same page, I know you know this, but here's just understanding voltage and amps and watts, understanding like how each component supports different amps. Like if you look at this, here's just an example in a chain. This power supply 12-volt output is 12.5 amps. Well, that fork terminal can support 8 amps. That 18-gauge wire supports 10 amps. That crim terminal supports 7.5 amps. Our header, the 0.156 header, supports 7 amps. So how much, like what fuse do you need in this chain, or what is this? Like your weakest link here is a 7 amp, which means I might want a lower fuse than that, because again, it's 7 amps. I'm hurting this thing. I want my fuse to blow, not melting this connector. So this isn't a specific example. This is just showing like, hey, when you're looking at current ratings, you can't be like, well, my power supply is this. I'm like, well, what's your wire? By the way, what is your wire rating? What's the wire rating on 18-gauge wire? Is it solid or stranded? What's the material? How much voltage is it? What's the temperature of it? You got to look at your wire spec. Do you have a wire spec? If you don't have a wire spec, that's because you bought wire from Amazon, which you should not buy wire from Amazon. When you buy wire from real places, they have the spec, and you look at the spec and you make sure that the wire is within spec.
The funny thing I've seen multiple times is that, the temptation kicks in, because sometimes, when you're more is better when it comes to cost. So it's like, hey, I just spent $15 more and I got a 60 amp 12-volt power supply. Well, that all sounds good, but now you're going to spend a ton of money in the architecture after that power supply because there's nothing in our system that handles 50 amps. So if you want to go arc weld at 12 volts, that's great, but that's not what we're doing in the pinball machine. So what this means is that you need to have wire gauges, you have to have fuse blocks and everything else that sits there and gets that to a current suitable to come into the ecosystem. Otherwise, if something goes wrong, it's not going to be the experience that you want.
Yeah, that's a great point. Like, if your power supply is 30 amps, I'm afraid of it because, like, oh my God, that means like this could put out 30 amps. Like, if there's a short or something happens, like this thing's putting 30 amps and I got nothing in my machine. Like I said, designed for 30 amps. That's like your kid that just turned 16. You don't give them a car that goes 0 to 60 in 2 seconds.
And you're up to 10 gauge wire. And I believe, you have to check the charts. I'm pulling this off the top of my head. But I believe at 30 amps, that's 10 gauge wire. Now you have to have a different wire gauge. Yeah. and now you have to go to a fuse block that can handle that type current and put those first fuses in to drop it down to 7 to come into, the filter board.
So this whole guide on fuses and fusing shows how you've got more current going into your board, you break it onto separate circuits, and it's just sort of walking through all that math. It also talks about planning for your circuits. So like, if you have a 12.5 amp power supply with 2 wires, now you've got 6.25 amps per wire, that's good. If you have 3 wires or 5 amps each, it's just really going into, how you figure out what your load is, experiment or math, or both. How to understand like current ratings, because this device has this much current, but it's at 5 volts and not 12 volts. So we just go into all this and explaining like everything that you need to know, what these capacitors are doing, how they work, all that sort of stuff. So next, now you got your filtered, clean, fused power. Now we actually get to wiring the Neuron controller itself. And so this is the Neuron going into your back box. We've got the power to the Neuron from the power filter board. You've got the intelligent smart connection here, which is sharing that current and voltage and fuse monitoring. You've got your power switch connections. You've got your PC connection, which is on your USB. Your various expansion bus and wire loop networks going down your playfield interchange. We don't have to walk through all these right now, but this is just explaining. You put the Neuron in. Here's all the things it's explaining. We give you a tour of the Neuron, like all the different things that are on it, what the connectors are doing. Basically everything that you look for there. Oops. And all this is covered sort of in that Neuron wiring. And then, by the way, for every single connector here, we show you. Oh, weird! They disappeared. Probably because zooming in is weird. It shows you like where you can read more about all those details. So next we go to our playfield interchange board. Playfield interchange board is my favorite board in the entire.
I love this board a lot too. Yeah. We have a little demo out on the floor right now, just showing a playfield being ran by the Neuron, and it consists of 3 RJ45 cables and 1 power cable coming in. So you unclick 4 things, you can pull the playfield out. That's it. But what this is also doing is you can kind of see, a whole bunch of extra connectors out here because, 12 volts is needed all over a playfield to go run things like, other boards, go run some optos, anyway, it's always such a hassle because you have to put terminal blocks somewhere or something on the playfield to go expand all of your buses out for 12 volts ground and what have you. So one thing so nice about the interchange board is that we allow enough connectors in there that you can sit there and pretty much bring everything back to the back and then just go branch those out to the boards needed and good to go.
And all the connectors here fit, like it's the same number of pins in the same order, the plug to the filter board, the plug to the cap, everything is all like sort of designed to match each other. So this interchange board, it's small, it's at the back of the playfield, and it does all your distribution for the things. So we sort of explain all that. Next, finally, we're doing playfield I/O boards. So the I/O boards, these are part of our I/O loop. This is what's doing your switches and your drivers. So the very first thing is we explain how to do your actual I/O loop wiring, which if I have here, like here's the back box with the Neuron controller, here's the playfield, and then here's your cabinet. And so this is just a continuous loop. There's out and in. Your Neuron will go down to your cabinet board in, your cabinet board goes out to your playfield, they loop through all your playfield boards, and then loop back together like that. So this is fairly straightforward.
The nice thing to know about this is that the order that the boards are in is the way they appear to the software, so they automatically identify themselves. So the very first driver board is going to be driver 0. The very first switch will be switch 0. And as you add boards, it just expands for that number automatically. So that's kind of a cool feature.
Yep. And you can query the boards also and get their ID and get their processor ID and everything. So if you want to write your software so you can change the order of the boards, that's all fine. All right, so now it's like switch wiring. And switch wiring, this drawing is showing an I/O board. And various I/O boards have various combinations of switches and drivers. There's a switch header on the board that has a few switch ground returns and switch outputs. And it's pretty much just like plug in your switches, plugging them in. Regular mechanical switches are okay. So we show you which ones left, right, like open, close, return, doesn't really matter. All the switches in Fast Pinball modern platform are direct switches. There's no matrix switches.
Correct.
So if you have any old machines that have matrix switches with diodes, cut the diodes off. You don't need them, just cut them off. We show also like, every switch header has 8 switch inputs and then a few grounds. And so you can run one ground wire to a bunch of switches. So here I made the purple wire bigger just to emphasize it. But you see the one purple wire can like snake through, and then each individual orange wire comes back for switch inputs. The switch inputs here, I show people like this board is a 1616, so it's got 2 different banks of switches. What's important is any switch on the same driver board is okay. So see here is like these two.
Let's talk about that 1616, just so everyone knows.
Oh yeah.
A 1616 means it has 6. The first number is the number of switches. The second number is the number of drivers. So a 1616 has 16 switches and 16 drivers. A 3208 would have 32 switches and 8 drivers. And our smallest little guy we all love so much is an 0804, so that has 8 switches and 4 drivers.
Love it. And when you have driver boards or I/O boards with more than one switch output, your switches, both legs of a switch has to be connected back to the same board. So see here, like even in the middle one where you've got, or the one on the upper right where you've got like one ground to one and the different jacks, like that's okay. But this here where like one leg goes to one board and the other leg goes to the other board is very bad.
And the reason, let's discuss this really quickly. Remember I talked about all these boards are floating. They can float by multiple volts between boards. If one's firing a flipper and one is not, the grounds will not be the same on those 2 boards. So by tying this little thin wire with this 22 gauge wire between those 2 boards, what you're trying to ask that little thin wire to do is like, hey, can you make both these boards the same voltage? And it's like, even though it's only fractions of milliseconds, that will probably work. It also may cause switches to read. And anyway, and if something does go wrong, like your main grounds come off, now all of a sudden this can be a fire hazard because that's going to be carrying all the current for the coil now that don't do it. Yeah. Okay.
And it's
just
funny,
don't do it.
They'll carry all the current only if the switch is closed.
Yeah.
And so your ground became disconnected, and then this one target you hit and it blows everything. It melts a wire and blows it. And it's like, yeah, just plug them back to the same board. The overhead thing is going. I don't know if you guys hear that, but it's like crazy for us. The other thing I'll say about switches is that for our auto fire rules, like when you have a button that's controlling a flipper and it's like very fast response being handled in hardware, in the Neuron platform, it does not matter what board that switch and that driver is plugged into. So the switches operate separately from the drivers. It's that I/O loop that's keeping everything, like all the data communication, super fast and in near real time. So you can plug any switch and any driver into any board and still make the rules for auto fires however you want. So this is regular mechanical switches. All the stuff is in here. There's a whole separate section on opto switches and opto switch wiring. An opto switch is basically just a switch where the sensor is light. And so we explain like how to have the infrared lights set up. We sort of explain also like just how to wire your opto receivers. We have a little fast opto emitter, which we sort of show you how to do. So that's all pretty straightforward. We've got just like 5 more minutes to do another few topics. Moving on to our solenoid and our driver wiring. This I like as a starting point because it explains like how a fastboard actually fires a driver. Like the 48 volts goes into the coil itself. So that coil is like always ready to go with like 48 volts like potential kind of sitting there. And all that fast driver board is doing is just like grounding the other leg for that.
God, you make it sound so simple.
I mean, I don't know. Look at this diagram. There's like 3 colors.
It's true. That's how it works.
It's PowerPoint engineering. What else is there? Yes, you want a diode. Can you put a diode on a fast? Like why do we need diodes? Why didn't we put these diodes? Why don't we build diodes into our I/O boards? because we don't know what you're doing. Is it a magnet? Is it a motor? Those are different things. Are fast IO boards, you can run at multiple voltages, 48 volts and 12 volts side by side in the same board.
Yeah, so we don't differentiate our drivers. Like, hey, we are switching to ground because we don't have them there. You can switch any supply. It could be 12 volts that you want to switch some little DC motor to do some little spinning top or whatever else. Yeah, because we don't have those, you can basically run any voltage, DC voltage up to, we used to go to 70. I'm not going to say 70 anymore. 48 is a good number. UL likes 48, so we'll just say 48 and below.
Yeah, it's and the diodes cost 5 cents. So someone the other day in Slack was like, "What? After wiring all these diodes?" I'm like, "You're building a pinball machine, dude. You're wiring 40 trillion things. Like, spend $1 on diodes." Because the thing is, it'll work without diodes. It's just you lose your protection. So it's like, yes, you can use your car with no oil and no seatbelts, or you can put oil in the engine. So explain how this sort of thing works. If there's multiple coils, it's just each one. You can share the 48 volts. Your 48 volts, you can daisy train from coil to coil to coil. They all have their own ground return to actually fire them separately.
But we should do a brief topic on that. So one thing to keep in mind is, yes, you could sit there and wire every single coil together in your pinball machine. That's great. But remember, there is a loss in this. If you have a magnet out there that you want to leave on for a duration of time, and you're sharing that with your flippers, like another huge source, you probably do want to run an extra 48 volt wire just to that magnet, and then sit there and run a separate one over to the flippers, because that's nobody likes that, like, once a flip, it's like, oh, there's no power, and then it's like, oh, it must be the hardware or something, but it can be the wire, so yes, if you're firing that magnet and it becomes weak, dang it, put another wire on that magnet for that 48 volts.
And we talked about a rule of thumb, and in the, I'm looking at the photos from the documentation, but in the documentation we talk about, your high current, I have like a bunch of flippers at once, run multiple 48 volt wires to them. They can all be on the same IO board, just multiple 48 volt wires. We also talk about toxic ground. I won't go into it too much right here, but, remember how we talked about the ground lift and like the current and all that stuff with coils. When this IO board makes this connection and grounds that coil, that ground, that's when it's turning off. But when it's making that coil on, remember we saw that ground lifts? So you don't want that ground to be the same ground from like your logic ground. Now, if you wire everything properly with our stuff, we show you like your driver control line goes back to the board, and this is a toxic ground going back to your playful interchange board on a specific toxic ground line. It's hard to mess it up if you like play everything incorrectly, but we call it, like, I put those like neon pink behind it to show like toxic ground is a different set of wires than your DC digital ground.
And don't look this up on the web unless you're on our website. There is no real word toxic ground, but it is something we like to use internally to just describe people like, hey, this is a toxic wire, leave it alone. That is for the coils. Do not put that on your LEDs. Run that all the way back to that main, and you'll be good. But so anyway, toxic ground should be considered, it is the one that moves the most in the system. So be aware of it.
Not getting a response back. I guess ChatGPT is from September 2001, which is before I joined FAST. So all the toxic ground reports the soil or land. All right. I love you can see my other like searches here. East German pulse phones, PinDevCon, robotic surgery precision. This is the new like what am I saying? Like the new Google history. It's search history. All right, so that's your driver wiring. We got just a minute or two left, a couple other things. So again, we're walking through in the documentation, all this kind of stuff. The cabinet IO board I want to talk about, because we have a separate IO board. It's like our regular IO boards, but it's designed for going in your cabinet. So it has some like extra low voltage drivers that are meant for like the flashing start button and like the LEDs inside your coin door. It's got a ticket interface, bill reader interface, a coin door interface. And so we just explain, and it's got its own dedicated connector on the playfield interchange board because these guys thought that up ahead of time. But like here we show, for example, like how to wire it to your cabinet devices, lighted start button, your flipper switch, your plumb bob, coin door interface switch. We explain how to like wire up to what a coin door interface is going to look like and how you wire this to your coin door. We explain how your what else in here, like the bill validator and like how to read it. We actually were sitting in your dining room table with the bill validator, like putting money in and like It's like, look, it's a $5, it's a $1, trying to tell.
It's so hard because we don't use cash anymore. So it's like we're so excited. We got this all hooked up. And oh my gosh,
Who has
do
money?
we have any bills?
Yeah.
So anyway, I had to go through in some drawer and we found a 5 and a 1. So at least we were able to test with those. The 1 was pretty wrinkled, but it did work in this case.
And then let's see, we got flipper wiring in here next. So not a lot to talk about here in this session. Just explaining the dual wound. We want dual wound with EOS, what you want in fast land, and we'll just leave it at that for now. Oh my gosh, expansion board and LED wiring, overhead announcements coming in. But
well, since this was mostly about wiring, I don't know that we're kind of getting to the end of our seminar. We should probably take questions from the audience here if they have any questions. But I think that's almost another topic because
I mean, hey, it's all here, right? LED wiring, audio and speaker wiring. We have our fast audio interface. We talk about that sort of stuff and like how to wire the speakers, how the power on detection works. Oh, you can see this is sections from here on down are not yet written. So here, congratulations, you hit the end of the internet, and it's 1:58 p.m.
All right,
so we got 2 minutes.
We got 2 minutes for questions.
If anyone has any questions, we're happy to, but we're always online. You can find us there.
Okay, so that's a good question
about dual. Like, why did we say we always want dual wound flippers?
So there's several reasons. Number one is, they have to be strong enough to do the main coil operation, and then you go into pulse width modulation to go do that. So pulse width modulation in a testing lab, you have to kind of know what you're doing because it's like, frequencies send out oscillations on there, almost a dead short in there. So it's like a little bit harder to sit there, wire lengths start to become an issue and all that kind of stuff, right? The other thing is that, it's like depending on the coil, depending on the way you wire it and things, it's like it is putting havoc on diodes and other things. We also have other protections besides diodes we put in. It's kind of unique on the way we did our boards. We have transient voltage suppression. So if you keep pounding on the door of that thing, their failure mode is to blow shorted. So they may go as well. Then you might need something like a snubber or something. But anyway, it's all in the name of safety why we do this. What's that TVS for? It protects the MOSFET.
And by the way, people are like, but Stern doesn't use dual wound. Well, here's the thing. Stern designed their own cables, their own control system, their own software, their own wires. They have more like engineers working for them than we have people in this room right now. So you're not Stern. When you're making 10,000 pinball machines a year, you can do engineering to tune perfectly your PWM to your wire to your coil. You're making one machine as homebrew, use dual wound.
Yeah, if you want to do all the math, more power to you. Just go do it. But mileage may vary, okay?
All right, we're getting the hook because our next session coming up is coming in back there. So, hey, thank you all for watching this. Everything we talked about, as you see, is online. fastpinball.com/docs or fastpinball.com/wiring. By the way, you can go to any headline here and you see that little P thing. You click that, and that gives you the link when it jumps to that tag. So you like this. Why we recommend dual wound flippers? I post this like once a week in a Slack. So welcome to, thank you for attending us to the initial PinDevCon. Thanks to our sponsors, Fast Pinball, CoinTaker, and Planetary Pinball. Happy pinball building out there. Dave, thank you for making the documentation writing easy.
Thanks all for coming.
All you, thank you so much.